Good morning everybody, and once again welcome back to the video. In this video I'll try to attempt to teach you about slowly changing dimensions and how you can implement that using PySpark or maybe in a lakehouse architecture such as using Apache Hudi. So the first question that comes is, hey, what is slowly changing dimension? So slowly changing dimension is a key concept in data management that helps you to track the changes in data over the time. This is particularly used in data warehousing and data analytics, where historical trend is very important. So now that you know what a slowly changing dimension is, I'll show you a small lab as well. But let's understand what are the type of slowly changing dimension. There are various types such as type 1, type 2, type 3. Type 1 in a basic language is, let's say you have a customer who lived at Seattle and now he moved to Stanford. So basically you simply perform an upsert, that is a type 1. In type 3, basically what you do is basically you would have a column called isCurrent, and when the new record comes in, for example where the customer is now in Stanford instead of Seattle, you mark the previous one as false and you mark the new one as true. That is essentially type 3. And I guess if I'm not wrong, in type 2 what happens is you have a column called isCurrent, and also you have an effective start date and end date. So anytime you have a new record, you essentially expire the old, mark that as false, and then essentially insert a new one. So these are the type of slowly changing dimension, that is type 1, type 2, type 3. Now let's see how you can essentially implement a slowly changing dimension in this video. For learning purposes, I do have a class which generates some fake data. So first we're gonna import them, then we're gonna create a Spark session. I have a method for generating some fake data. And now I'm gonna show you how the data frame looks like. This is a sample of a data frame, how it looks like. As you can see, we have a customer ID, a name, state, city created at, a customer dimension key, and isCurrent. So what we are going to do is we're going to essentially now perform an upsert on the Hudi lake, data lake, or the lake house, right? And then we are going to implement a slowly changing dimension. We're going to update Kelly. She moved from Illinois to Stanford. So let's consider that scenario now. As you can see here, now I'm performing an upsert on the Hudi transactional data lake by calling a method called upsert Hudi tables. I'm passing the database name, the table name as dimension customer, the record key as customer dime key, which is a unique identifier, precom key used for dedupe purposes, which is created at, copy on write, and method as upsert. Let's implement an SCD, right? So here you can see this is the old customer, name as Kelly, state as Illinois, and city as Lake Megan, again some fake one, right? This is the new information. Let's say she moved from Illinois to Connecticut in city Stanford. So here you can see I did create a Spark data frame called update df customer, and this is how it looks like. The customer ID is the same, the name is also the same, the state is has been updated. Again, we are gonna implement an SCD. I'm just showing you the Spark data frame. The city as Stanford and isCurrent as true. Now, what we need to do is basically we need to locate Kelly in the in the dimension table, and then we need to mark the isCurrent value as false. Before that, we need to create a snapshot. Here you can see I am essentially creating a snapshot for the old data frame and the new data frame, right? As you can see on line number 3, that is the new updated data frame that we received, where the state and city was updated, right? We create a temp view called new customer, and again we are loading the old data into a temp view called old customer. Let's take a look at the Spark SQL query, right? So again, pretty straightforward. We are selecting the customer ID, the name, the city, the email. So we are selecting everything from the old customer. And what we did is basically we are adding a column called false, which is isCurrent. So basically what I'm saying is select everything for Kelly, and then for isCurrent column, set that to false, right? And here you can see we selected that from the table called old customer. We did an inner join with the new customer, right? So hopefully that made sense. So let me show you how the data frame looks like. Let's take a look at the output. This is how the output looks like. As you can see, the name is Kelly. The state is Illinois. This is the old one, right? Illinois, city as Lake Megan. What you want to observe is over here, isCurrent is set to false. Meaning I essentially have located Kelly and I have set the isCurrent value now to false. So the next step is we simply need to merge this old one and the new one, and then perform an upsert on the dim table. That's pretty much it. So let me show you what I'm talking about. Again, over here on the top, you see Kelly. This is the old data frame where the city is, the state is Illinois, and observe is current is set to false, right? So before that it was true, we now set it to false. This is the new record for Kelly, and she moved to Connecticut in Stamford, and over here is current is set to true. Now it's pretty simple, right? We just need to merge and then perform an upsert, right? So let's take a look at that process. Over here, as you can see, I'm simply merging the two Spark data frame, and now let's take a look at the output over here. This is how the output looks like. As you can see, I have merged the data frame, and here I have the old information about the Kelly, where the is current is marked as the old information about the Kelly over here, where is current is marked as false. This is the new information about Kelly, where she moved to Stamford, Connecticut, and is current is set to true. So now I can essentially see the changes. First, Kelly was in Illinois, now she moved to Connecticut, etc., etc. Now, the only thing that is left is we need to perform an upsert on the Hudi transactional data lake, which I can do so by calling upsert Hudi table. After performing the upsert, now let's read and see if we have the old and the new information. So over here, as you can see, I'm again creating, I'm reading from the Hudi transactional data lake, and I'm creating a temp view called customer. And here you can see, I wrote a simple Spark SQL query. I'm selecting everything where the name is Kelly Perez. So now I can see the historical trends or the changes, right? So basically, oh, you know what? Kelly was in Illinois here, and then she moved into Connecticut, Stamford, right? And this is the most recent one, right? So that is how you guys implement slowly changing dimension in PySpark and Hudi Lakehouse. Thank you so much for watching. If you have any more questions, let me know your questions in the comment section below.